Mia knows 31 people and randomly invites 3 to a dinner party. What is the probability that Amia, Lexington, and Shea are selected to be invited to the dinner party? Does it matter if Amia was picked first, second, or third?
No. Yes.
No, it does not, Amia, because you're going to a dinner party. Okay, if you were picked first or second, you wouldn't even know it. I mean, there's no difference between being picked first, second, or third in this case. You're just getting an invitation. Everyone's getting the same thing, an invitation to a dinner party. This is going to be a combination because the order is not important. Order not important. Yes, there will be hors d'oeuvres. Important. Combination, order is not important. We're not going to invite Amia and then Amia, and then Amia. That would just be weird, right? Like, I've invited 3 people, and they're all you. Okay, it's sweet, but it's kind of mathematically wrong. If you're inviting 3 people, they would have to be 3 different people. It's without replacement. Without replacement. The formula for this is n factorial over n minus r factorial divided by r factorial. Or you can work it out logically. You could say there are 31 choices for the first person times 30 choices times 29 people for the third. Because the order doesn't matter, we're going to divide that by 3 factorial. Right? Because there's 6 ways to order them. We want to turn that 6 into a 1. So we're dividing by 3 factorial. Or we can use this formula, which is 31 factorial divided by 31 take away 3 is 28 factorial divided by 3 factorial. Let's just run that through the calculator. Also, a lot of people are not dividing this stuff right. There are people that are getting all the way up to here, and it's perfect so far. But you're losing marks because you're doing something crazy. 31 factorial, don't look at it, it's a huge number, divided by 28 factorial, then you get a more reasonable number, okay? So 26,970. Here's the question. Am I multiplying by 3 factorial or dividing by 3 factorial? I'm dividing by 3 factorial. There's 2 ways you can do this. You can press divide, again, by 3 factorial. 3 factorial equals 4495, which is the right answer. There's 4,495 ways that Mia can invite 3 people randomly to dinner. The other way of doing this, by the way, is you could do 31 factorial divided by, open bracket, 28 factorial times the 3 factorial. 3 factorial, close the brackets, and we still get the same answer. It's good. What's the probability that Amia, let me close this, and that Amia, Lexington, and Shea are invited? So the probability that Amia, Lexington, and Shea are invited, well, that's just one outcome out of the 4,495. That's it for the test. Have a good night.